In a moment destined to echo through the halls of scientific history, the James Webb Space Telescope has unveiled something extraordinary.
One of the greatest scientific missions of modern times has taken a giant leap forward today with the launch at lunchtime of the James Webb Space Telescope.
Something that will alter how we look at the universe forever. For the very first time, humanity has captured a real, direct image of a planet orbiting a star beyond our solar system. This is not a simulation. It is not a computer model nor an artist's rendering. This is the real thing. Light from a distant world, seen through our own instruments, sent across the vast gulfs of interstellar space and transformed into a visible, tangible image. What we are witnessing is a revolution in space science, a turning point in our understanding of the cosmos and our place within it. For centuries, the question of other worlds has haunted human imagination. Ancient philosophers speculated about the existence of other Earths, while medieval theologians pondered whether the heavens held other forms of life. In the 20th century, as our telescopes grew more powerful and our ambitions bolder, we began to discover exoplanets, thousands of them, orbiting distant stars inferred through the dimming of starlight or the subtle gravitational wobbles they caused. But until now, they remained hidden in shadow. We knew they existed, but we could not see them. That era has now ended. Before we dive into this astonishing discovery, make sure to smash the like button, subscribe to the channel, and ring the notification bell to stay updated as we continue exploring the deepest mysteries of the universe together. At the heart of this new era is the James Webb Space Telescope, launched in December 2021 after more than 2 decades of development. A joint project of NASA, the European Space Agency, SAS, and the Canadian Space Agency, CSA, Webb was designed to be the most powerful space telescope ever built. And now, orbiting in deep space nearly 1 million miles from Earth, at a gravitational balance point called Lagrange Point 2, Webb has proven its worth. Its near-infrared instruments have now done what no previous telescope could, captured the light of an actual exoplanet. This world, a gas giant several times the mass of Jupiter, orbits a young star still enveloped in a faint, dusty nebular glow. Located hundreds of light years from Earth, this system lies far beyond the edge of our solar neighborhood. But for Webb, distance is no obstacle. With its massive gold-coated mirror, precision instruments, and pioneering coronagraph that blocks out starlight, Webb was able to isolate the dim glow of the planet itself. What emerged was a clear, resolved image of a world that has never before been seen. Not imagined, not inferred, not illustrated, but seen. And what a world it is. The image reveals a slightly flattened sphere, a shape caused by its rapid rotation. Bands of color swirl across its surface, suggesting complex atmospheric stratification. Subtle auroras at the poles hint at the presence of a magnetic field. Tiny dimples in the planet's brightness suggest the presence of storm systems, possibly even the gas giant equivalent of Jupiter's Great Red Spot. Spectroscopic analysis has already identified the telltale signs of methane, water vapor, and possibly even complex organic molecules in the upper atmosphere. While this gas giant is far too massive and too hot to host life as we know it, the chemical richness of its atmosphere makes it an ideal candidate for studying planetary formation, weather dynamics, and the preconditions for habitability elsewhere. What makes this image so historic is not just its beauty, though it is beautiful beyond words, but what it represents. For decades, we have relied on indirect methods to detect exoplanets. The transit method, which watches for dips in starlight as a planet passes in front of its star. The radial velocity method, which measures the gravitational tug of an unseen companion. These techniques have revolutionized astronomy, allowing us to catalog over 5,000 exoplanets, but they offer only partial glimpses, estimates of mass, orbit, and size. Webb's image gives us something wholly new, a complete light profile, a direct spectrum, a full picture of a real alien world. And this is only the beginning. Already, scientists are poring over the data. Every pixel of light captured in the image contains layers of information. Infrared emissions tell us about internal heat and circulation. Reflected light patterns help calculate albedo or reflectivity, which in turn informs us about clouds, surface composition, and even possible weather systems. Over time, as the planet rotates, light curve analysis may reveal details about day-night cycles, axial tilt, and seasonal changes. This is not theory, this is not guesswork, this is real data from a real world. And with this data comes a wave of new questions. If we can capture the image of a gas giant orbiting far from its star, what else might we soon see? Could future telescopes with larger mirrors, finer sensors, and more advanced choreographs capture similar images of rocky, Earth-sized planets? Planets with oceans, continents, and cloud formations like our own? The answer is yes. The technology is not only imaginable, it is in motion. Plans for the next generation of space telescopes, such as the Habitable Worlds Observatory and the LUVOIR mission, are now gaining momentum. The dream of seeing an Earth twin, a pale blue dot complete with weather systems and maybe even biosignatures, is no longer a fantasy. It is an approaching possibility. Beyond the laboratory and the observatory, this image touches something deeper. It inspires. It stirs the same primal instinct that once drew humans to chart the oceans, climb the highest peaks, or send rockets to the moon. To look up and to wonder. To ask, what else is out there? And to know that we are beginning to answer that question not just with hope, but with evidence. For educators, this image becomes a powerful tool. No longer do we need to rely on artistic imagination to teach about exoplanets. We can now show students the real thing. It makes the concept of other worlds more immediate, more accessible, more thrilling. Students can now learn about planetary spectroscopy, orbital mechanics, and atmospheric science by looking at a real alien planet. The image also unites the world in scientific curiosity. This achievement was not the work of one country or one agency. It was the product of decades of international collaboration. Engineers, scientists, administrators, visionaries, and funders working across borders toward a common goal. And that unity speaks to a deeper truth. When humanity sets aside its divisions and works together, there is almost nothing we cannot accomplish. We can capture the light of a planet hundreds of trillions of miles away. We can pull back the curtain on creation itself. From a philosophical standpoint, this achievement is humbling. It challenges our assumptions about uniqueness. It forces us to expand our definition of what a world is. When we see the glowing orb captured by Webb, we must ask, what stories play out beneath those clouds? What histories unfold in alien atmospheres? What forces sculpted that world? And, perhaps most hauntingly, are we truly alone? While this particular planet is not habitable, its image proves that the search for life-supporting worlds is no longer just a matter of indirect inference. It is becoming a matter of observation and measurement. With continued exploration, we may one day observe planetary atmospheres containing oxygen, ozone, or other biosignatures, fingerprints of life etched into the chemistry of the cosmos. And when that day comes, the groundwork laid by Webb's first image will have made it possible. This milestone also forces a reassessment of how science is communicated and understood. For too long, space exploration has been seen as an elite endeavor, something reserved for labs and lecture halls. But this image, by virtue of its visual power, speaks across disciplines, across borders, and across generations. It is not a statistic, it is not a hypothesis. It is a world, vibrant, visible, and real. A world that was once invisible and now is not. And so, as we gaze at this first real image of a planet beyond our solar system, we are reminded of what drives us, not just as scientists, or students, or stargazers, but as humans. The need to know, the hunger to see, the belief that truth and beauty lie just beyond the horizon, waiting for those bold enough to seek them. This image is a promise that the universe is not closed, but open, not silent, but full of stories yet untold. As more light arrives from distant systems, as more images are processed and revealed, we will not just build a catalog of alien worlds, we will build a map of possibility. We will look back on this first image as the one that changed everything, the one that opened the door, the one that proved what once seemed impossible, that we can see beyond the stars, and what we find there will both astonish us and bring us closer to understanding who we are. So if you're watching this today, know this: you are living through the dawn of a new cosmic age. You are witnessing the first chapter in a story that will stretch across generations. A story that begins not with a telescope, but with a question. What lies beyond? And now, for the first time, we are starting to answer that question with images, with light, with knowledge. The release of the James Webb Space Telescope's first real image of an exoplanet marks a historic milestone not just for science, but for all of humanity. For decades, we have dreamed of seeing other worlds. We've speculated, we've modeled, and we've relied on indirect evidence. But now, that dream has taken a tangible form. We've crossed a threshold from theory into observation. For the first time, we are not imagining what a distant planet might look like. We are seeing it. This achievement forces us to pause and reflect on what it truly means. At the surface, this may appear to be just another scientific advancement, but in reality, it represents a major shift in our relationship with the universe. The ability to directly image another world confirms that our tools, our technology, and our scientific understanding have matured to a level once thought impossible. It shows that humanity is now capable of not only detecting distant planets, but of observing them in enough detail to analyze their atmospheres, their dynamics, and their chemical makeup. This single image is the product of decades of planning, engineering, international cooperation, and persistent curiosity. It is a reminder that progress takes time, often more time than we expect, but it is possible when there is commitment, collaboration, and a clear goal. The James Webb Space Telescope is not just a scientific instrument. It is a global effort that united countries, agencies, and disciplines to work together towards something larger than themselves. It is a symbol of what we can achieve when we pursue knowledge with patience and purpose. Seeing this exoplanet, a gas giant many times the size of Jupiter, in such remarkable detail gives us a new sense of what's truly out there. Although this planet is not hospitable to life as we know it, it opens the door to the next great goal: identifying rocky, Earth-like planets that may very well be habitable. What was once science fiction, visually confirming the existence of other worlds, is now science fact. And it's not difficult to imagine a future in which similar images show us blue oceans, green continents, or even atmospheric signatures that hint at life. This discovery also has practical consequences for how we study the cosmos. For years, astronomers relied heavily on indirect methods to detect exoplanets. These techniques, such as the transit method or radial velocity, have given us thousands of discoveries, but always through inference. Webb's image represents a new phase in which direct observation becomes possible. Every pixel of light in the captured data contains information that can be broken down to reveal temperature differences, cloud composition, rotational speed, and more. This is not just a milestone, it is the beginning of a new scientific era. Beyond the science, this moment carries deep educational and cultural value. For students learning about space, this image makes the idea of other worlds feel real. It is no longer necessary to rely on artists' impressions to describe what a planet beyond our solar system might look like. Teachers and scientists now have an actual example to point to, something grounded in observation and data. This will shape how astronomy and planetary science are taught for generations to come. It also inspires curiosity. Children seeing this image today may become the scientists who one day take the next step, perhaps even finding signs of life. For the general public, the image serves as a powerful emotional symbol. It reminds us that the universe is not just a vast, empty space filled with distant stars. It is a rich, complex, dynamic system filled with other planets, some unimaginably different from our own, and some that may be strangely familiar. The sense of awe that comes from seeing a planet so far away, not imagined but photographed, is something that connects across cultures, languages, and beliefs. It stirs something universal, the desire to explore, to understand, and to find our place in something larger. This moment also prompts important philosophical questions. We now know with certainty that planets orbit other stars, and we can now see them with our own instruments. What does this say about our uniqueness? What does it mean to be human in a universe filled with worlds? These are questions that go beyond science and touch on the human condition, on how we see ourselves, how we define life, and how we interpret our role in the cosmos. In a world where conflict, division, and distraction often dominate the headlines, this achievement offers something different. It offers unity. It shows what humanity can accomplish when we work together for a shared purpose. The James Webb Space Telescope was not built by one country or one generation. It is the result of countless contributions from engineers, scientists, technicians, and visionaries around the globe. It reflects what we can do when we look beyond the immediate and focus on the long term. In that way, the image is not just about a planet, it is about potential. There is also a growing sense of urgency. Now that we've proven the ability to see distant worlds, the question becomes, what's next? Scientists, mission planners, and researchers around the world are already looking ahead. The success of Webb's exoplanet image strengthens the case for next-generation observatories, ones with even more powerful imaging systems capable of studying Earth-like planets. We are now on the edge of a future where discovering signs of habitability or even life may be within reach. In many ways, this moment is a beginning, not an end. It sets the stage for deeper investigation, more refined instruments, and increasingly ambitious goals. It gives us not only new data, but a new standard, a new reference point for what is possible. And it will no doubt become a cornerstone for future space missions, from orbital telescopes to interstellar probes. The bar has been raised, and with it, the expectations for what science can reveal. In closing, this image from the James Webb Space Telescope is more than a scientific result. It is a message, a reminder that even in a universe so vast and unknown, we are capable of finding clarity. It tells us that through curiosity, cooperation, and determination, we can answer questions once thought unanswerable. It tells us that the darkness is not empty, it is filled with worlds, with light, with stories waiting to be discovered. And most importantly, it tells us that the more we learn about the universe, the more we learn about ourselves. This is not just a view of a planet, it is a reflection of who we are becoming, explorers not just of space, but of understanding. And with each new discovery, we take another step closer to the stars, not as distant observers, but as participants in a much larger story.